My name is Shiv, and I'm the Chief Business Officer at Bosch AIShield, a corporate startup at Bosch. I'm here today to talk to you about the need to secure AI. Let's start with a case in point. What you see on the screen is representation of a pedestrian detection model. Now, this particular model was developed over 8 to 9 months with an investment of euro 2 million. As part of an ethical hacking case, our team extracted this model in less than 2 hours, of course, at a fraction of cost. And the eventual delta in the accuracy of the original model, as you see in the third image, and the stolen model was hardly 4%. The point which we wanted to make was that such threats and attacks can happen across the industry. And that is where we have to understand the importance of need to secure AI. Now, we just saw one example, which was on model extraction. As the organizations are increasing in adoption of AI, there are multiple threats named adversarial threats, which we see in the picture: model extraction, model evasion, data poisoning, and model inference. And the outcome of these attacks to an organization, people, or society at large can be financial losses, damage to the brand reputation, and loss of IP itself, like we saw in the extraction case. Now, we have worked with multiple organizations across the industry. Just to give some examples, an autonomous vehicle can malfunction due to adversarial threats. Misdiagnosis can happen in healthcare and medtech space. Economic instability can occur due to trading algorithms or equity algorithms not working as they are supposed to. And state-sponsored cyber attacks in the Industry 4.0 space are very relevant to this AI security importance. Also, what we are seeing, especially this year and in the coming year, is that multiple regulatory organizations are also seeing the need to secure AI. So FDA has released AI security guidelines for SAMD, software as a medical device. EU Parliament is working on an AI Act. ITSI, a telecommunication group, is working on securing artificial intelligence. And NIST recently called for comments for their AI risk management framework. So the overall objective has to be ensuring the security of AI so that it does not become a growth limiter to an organization's journey in AI related transformation. And we together have to work on introducing AI security as best practice and interoperability in the MLOps and cloud players space. Just understanding a bit more on these attacks. What you see on the screen is a typical life cycle of an AML model. You will see that we prepare data, we train model, we validate it, deploy and monitor it. Now the attacks which I talked about, the first one, data poisoning, which applies across an AML model lifecycle, be it preparing the data or deployment or when it's in actual use. One can inject malicious samples as part of the feedback loop to give different results. Then speaking of extraction, again, you can extract a model and cause replication, stealing of the IP, thereby unlicensed usage or further malfunctions and misdiagnosis. Model evasion, where you are evading the whole concept of an AI application. An example, camouflage from real-time video surveillance, leveraging adversarial patches. We have seen this particular across computer vision applications across the world. And the last one, membership inference, where you are accessing the data record, you're inferring the whole logic of an AML algorithm. A scenario can be compromised personal data when hackers infer the AML model or associate data in a banking or healthcare AI application. So what we see is that these attacks are prevalent, and that is where I want to talk to you specifically about a very particular use case, which is AI-based lending automation from BFSI space. Now, big data problem is suited to machine learning algorithms in the BFSI space. You determine credit worthiness as part of a lending automation exercise and utilize customers 360-degree information, credit history, job history, education, etc. And the cost of building such an algorithm is usually USD 20K to 1 million. Now, as an adversary, below are the steps which one can execute. First, reconnaissance, where I identify the data sets and the systems of that AML model publicly. I develop the resources as part of stage 2. I acquire similar data sets to that from the public space. The third and very important is posing as a legitimate user to access the ML model or an actual user with a malicious intent. The next part is querying the model. I'm actually staging an attack over here. I'll query the model and train a model that replicates. Now, because I have now replicated a model that one had built, I have actually stolen it. I've violated the IP, and it can be used for unlicensed usage and launch further attacks. Speaking of further attacks, I can generate adversarial examples to transform to the original model and use these adversarial examples to evade the AIML model, thereby causing a model evasion attack. Let's see a bit of representation that we did over here. So what you see is that an organization had built this credit scoring model, recurring neural networks. And what an adversary does is it uses a query engine to query this particular model. Of course, stage 3 has been done. I'm either posing as a legitimate user or an actual user with malicious intent, remember. And what I have replicated as part of this is an replication of the original model with the RMSE difference of what you see in the screen. The original one was 0.015 and the replicated one is standing at 0.047. So that is the delta, small delta, which as an adversary, I was able to extract this particular model. Let's see a bit of more examples via simulation. What you see on the screen is a simulation exercise that we did for different use cases. So if the question is your AI secure? What you have to do is you just select one of the AI models. Let's say I'm on image classification itself. And what you're seeing on the screen is an input image and its output. Now, if I'm launching an attack as an adversary, I have two attack types, either black box or gray box, considering if I have how much reconnaissance or resource development I could do about the architecture or the sample data sets of that particular model. Let's say it's a gray box attack. I'm selecting a particular set of queries via my query engine and launching the attack. What you see on the screen is the difference in the attacks with or without AIShield, which is an AI security solution. Now, without AIShield, I was able to get an accuracy of 60% on this particular algorithm while stealing it. But with AIShield, my accuracy only goes to 15%. So that is the impact of having an AI security solution in place has to your organization. Going back, what I would like to say over here is that in building AI security, what the AI ecosystem needs to do is to collaborate on AI security for enterprise scale. You see already some use cases listed from various industries which are in high adoption stage, be it from BFSI, Industry 4.0, healthcare, or automotive. Together, what we need to do is three things. One is talent and capability for AI security. How do we get people interested, evangelize, and build capabilities at the confluence of AI as well as cybersecurity? Second is addressing the vulnerabilities itself, which we talked about, the various type of attacks, how to detect them and how to mitigate them. And then finally, regulatory compliance, which is incoming very shortly within an year or two, as we saw initially. So these are the three things that we have to collaborate together. We have to look at the MLOps lifecycle, and we have to decide how to interoperate and bring in the concept of AI security across the lifecycle of a model. I would like to end with just this statement, which is very relevant because security has always been an afterthought. So when it comes to securing AI systems, it's hard to patch or mitigate what you can't detect as of today. So let's start detecting, let's do vulnerability analysis, and let's build defense. Let's generate and integrate defense mechanisms. Thank you.